Let's look at a problem that combines some of the important topics in general chemistry. When lead-2 sulfide ore burns in oxygen, the products are solid lead-2 oxide and sulfur dioxide gas. Let's break this question down into two parts. The first part is asking you to write and predict the products of a chemical reaction. The second part of the problem is the tricky part. Based on the chemical equation you just wrote, can you determine how much oxygen is needed if you have 30.0 grams of lead-2 sulfide? Think of the problem like this. Let's say you're trying to bake a cake, and the recipe calls for 1 cup of sugar, half a cup of butter, 2 eggs, 1.5 cups of flour, and half a cup of milk. Remember that that's the amount of stuff you need in order to make one cake. How much cake do you make if you cut all of your ingredients in half? Well, that's right. You only make half a recipe or half a cake. What happens if you multiply all the ingredients by 3? You would be able to make 3 cakes. Now here's the challenging part. What if you start with the original recipe, but instead of having 2 eggs, you just have 1 egg? How many cakes can you make? Because the amount of eggs is cut in half, that limits how much cake you can make at one time. In chemistry, we call an ingredient that limits how much product can be made a limiting reactant. In our problem, we have 30.0 grams of lead-2 sulfide, so how much product do we make? And how much oxygen do we need to make it? This is the heart of the problem we're dealing with. Let's look at the first part. Write the balanced chemical equation for the reaction. We know what our reactants are. PBS, solid, plus O2, gas. The products are solid lead-2 oxide and sulfur dioxide gas. Putting both sides of the equation together, we have PBS, S in parentheses, plus O2, G in parentheses, yields PBO, S in parentheses, plus SO2, G in parentheses. We often show the physical state of a substance using parentheses, S for solid, G for gas, and L for liquid. Before we're done, we have to make sure that this equation is balanced. Is this equation balanced? Well, we have 1 PB on each side, and we have 1 S on each side, which are balanced. But we have 2 oxygens on the left side and 3 on the right side, which are not balanced. To balance this out, the coefficient in front of the O2 should be 3/2, because the 3 comes from the right side and 2 comes from the left side. But we don't like having fractions in the left side. So we have to multiply 3/2 by 2 so that we just have 3 as the coefficient. Since we want to multiply that coefficient by 2, we have to multiply both sides of the equation by 2. So now the complete balance equation becomes 2 PBS, S in parentheses, plus 3O2, G in parentheses, yields 2 PBO, S in parentheses, plus 2 SO2, G in parentheses. This is our final answer for part A. Now let's talk about part B, which asks, how many grams of oxygen are required to react with 30.0 grams of lead-2 sulfide? What do we know about this problem? We found the balanced equation in part A, and we know we're starting with 30.0 grams of lead-2 sulfide. What do we want to find out? We want to know how many grams of oxygen we need to react with 30.0 grams of lead-2 sulfide. The next step is how do we go from grams of lead-2 sulfide to grams of oxygen gas? The plan of attack is to use the molar mass of lead-2 sulfide to convert grams of lead-2 sulfide to moles of lead-2 sulfide. Once we're at moles of lead-2 sulfide, we can convert to moles of oxygen gas because we know the chemical equation and the relationship between lead-2 sulfide and oxygen gas. Once we're at moles of oxygen gas, we can convert back to grams of oxygen gas by using the molar mass of O2. So we need to find 3 conversion factors. 1, how many grams of lead-2 sulfide are in 1 mole of lead-2 sulfide? When we calculate the molar mass, we find that 1 mole is equal to 239.3 grams of lead-2 sulfide. 2, how do we convert from moles of PBS to moles of O2? The equation that we solved for in part A told us that for every 2 moles of PBS we need 3 moles of O2 in order to make 2 moles of lead-2 oxide. So our conversion factor is 2 moles of PBS is equal to 3 moles of O2. 3, how many grams of O2 are in 1 mole of O2? This is just like the first conversion factor. 1 mole of oxygen gas is equal to 32.0 grams of oxygen gas. With these conversion factors, let's use dimensional analysis to find the answer to part B. Starting with 30.0 grams of lead-2 sulfide, we use the molar mass of lead-2 sulfide to write the first conversion factor as dividing 1 mole of lead-2 sulfide over 239.3 grams of lead-2 sulfide, so the grams will cancel out. Now that we're in moles of lead-2 sulfide, we can multiply by the next conversion factor, which is every 3 moles of oxygen gas equals 2 moles of lead-2 sulfide to cancel out moles of lead-2 sulfide. Since we need to find grams of oxygen gas, the next conversion factor is 32.0 grams of oxygen gas over 1 mole of oxygen gas. So moles of oxygen cancel out, and we're left with our final unit, grams of oxygen gas. Mathematically, this is 30.0 times 1 times 3 times 32.0, all divided by the quantity 239.3 times 2 times 1, which gives us 6.02 grams of oxygen gas as the final answer.